Hello, gentlemen. At the end of chapter 2, we had a little bit of a rush to the end. So this is section 9 from chapter 2. It deals with nuclear chemistry. Now, nuclear chemistry involves nuclear reactions, which are reactions inside the nucleus. Thus far in the class, we've only talked about chemical reactions. As we remember, chemical reactions involve two different atoms reacting together through their valence electrons to create ionic bonds or covalent bonds and sometimes metallic bonds, which we haven't talked about, but those are chemical reactions. But differing from that are nuclear reactions. And nuclear reactions are what happen inside the nucleus. So let's talk about some differences between the two. In the chemical reaction, bonds are broken and not formed, versus nuclear reaction. Nuclei emit particles and or rays. Those emitted particles and rays are known as radiation. Sorry, this should be bonds are broken and are formed. They can be broken and they can be formed in a chemical reaction. In a nuclear reaction, we emit particles and or rays, which is radiation. In a chemical reaction, atoms are unchanged but rearranged. Conservation of mass says you start with some particular mass and you end, things can get jumbled around, but in the product side, you still have that mass. If I start with carbon, hydrogen, and oxygen, I end with carbon, hydrogen, and oxygen. In my nuclear reactions, however, atoms can sometimes change into other atoms. If in a nuclear reaction I can emit particles, I can emit a proton. If I emit a proton, then my atom changes its identity. Chemical reactions involve valence electrons, whereas nuclear reactions involve protons, neutrons, and electrons. Those all can be emitted as particles. In a chemical reaction, there are small energy changes. When bonds are broken and bonds are formed, there are very small energy changes, whereas in a nuclear reaction, there are large energy changes. Large energy changes, and that's why we have our atom bomb, our atomic bomb that's so strong. And lastly, in a chemical reaction, the rate of a chemical reaction is influenced by concentration, temperature, pressure, and catalysts. Some of those we haven't talked about much in detail, but they're influenced by those outside environmental conditions. Whereas in a nuclear reaction, they're not affected by any of these things. And this is why nuclear radiation is around for so long in the atmosphere, because it's not affected by anything else. But why would a nuclear reaction even happen in the first place? Let's talk about that very quickly. Nuclear reactions happen because of nuclear stability. So in order for a nucleus to be stable, there must be a balance between the electrostatic force and the strong nuclear force in the atom. Now, in the atom, we have protons, neutrons, and electrons. Protons are positive, neutrons are neutral, electrons are negative. Now, electrostatic force is the force that charges feel on each other. As you know, opposite charges will attract each other. So my positive charge protons in the nucleus and my negative charge electrons in the electron cloud are drawn to each other, and that's why the electrons stay in the cloud. That's our effective nuclear charge. And we know that two positive charges will repel each other. But I have a lot of protons packed very tightly in my nucleus. How are they still there if they're repelling each other? There is a repulsive force on the protons, but there's also a stronger force that's keeping them together. So it's called the strong nuclear force. So in the red here, how do all these positively charged protons stay packed in the nucleus? Because of the strong nuclear force. This is the force that acts on subatomic particles that are extremely close together. So protons and protons are held together because of strong nuclear force. Protons and neutrons, because of strong nuclear force, are held together. And neutrons are held together through strong nuclear force. This force is stronger than the repulsive force the protons feel from each other due to the electrostatic force. Thus, the nucleus stays together. Now, the nucleus doesn't always stay together. There's a degree of stability. When we have atoms that have a smaller nucleus, they usually have a very stable nucleus. There's a good proton to neutron balance. But when atoms get much larger and their nucleus becomes much heavier, sometimes their nucleus is unstable. It's unstable because there's a force imbalance where the electrostatic force, meaning the repulsive force between the protons, becomes greater than the nuclear force holding the protons together. So at one point in time, when the atom gets to a certain mass, it gets so big, the repulsive force between the protons that pushes them away from each other gets larger than the force that's keeping the protons together, the strong nuclear force. When that happens, it causes particles to be emitted. Protons and things start just breaking off. It's unstable. We call that instability radioactivity. So this would be radioactive because it's emitting particles and emitting energy. Now, in our next video, we'll look at different types of radiation. Hope this helps, gentlemen.